And the last task of determining the vocabulary of terms is stemming and lemmatization. Stemming is nothing but cutting of the words, and mostly it would be of derivational effects. Whereas the lemmatization is just simply based on vocabulary and the analysis of a word based on meaningful parts contained within. It mostly involves with inflectional endings and writing the base word, which is also known as lemma. Basically, the goal of both stemming and lemmatization is to reduce the inflectional forms and sometimes derivationally related forms, which is commonly known as lemma. The most common algorithm of stemming is Potter's algorithm. Here the Potter's algorithm is nothing but the Foster stemming, where it consists of 5 phases. So each phase having its set of rules, and also each rule will be derived from its rule book. Here the rule SSES is derived from its respective group, which is matched to the respective word, and where ES is removed and only the SS is left. And the same IS, this rule is derived from its respective group, where ES is removed and only which is left with I. And also the the S is removed and left with empty, and changing the word cats to cat. And similar way, there are many other rules as well, in which, for example, the rule would map replacement to replace, but not cement to C. Stemmers is basically a very language specific rules, whereas the lemmatizer is mostly stick with morphological analysis, like identifying the lemma of each word. Coming to stemming, Potter stemming, if we take these respective examples like operate, operating, operators, and these things, it gives an output as oper. So if one searches for operational and research, it may even match with operational and systems. And we can't even help with lemmatizer as well, because it wouldn't be good. Even the morphological results also coming as operation or operate. So it would be matched with operational and operating, or even the operative, which wouldn't be the desired output. Now coming to the next topic, faster posting list intersection via skip pointers. Here basically the usage of skip pointers is to avoid the processing parts which wouldn't be the part of the results. So if we take an example from the upper list and the lower list, we can match 8 from both of the list. So now the 8 will be redirecting to 16, and in the lower list it will be redirecting to 14. Since the 16 is the lower number, we compare it with the 41, and the 16 will be redirected to its next skip list pointer, and then we will be checking whether the 28 with is less than or equal to 41. Since the 28 is less than 41, the 16 will directly redirect it to 28 instead of redirecting to 19. So with this process, we will avoid these two steps of matching with 19 and 23, through which we can decrease the time of the searching process. So there could be a number of variations of the skip pointer depending on what exactly you need to check. For example, if we take small skip pointers, it may take number of repetitions, but even if we take large pointers, we may even skip the middle. So upon the many examples, the best derived is if we take the length of the point list as p, so the best skip pointer would be its root p. For example, if 25 is the length of the pointers list, the skip pointer could be the root of 25, which is 5, which means these many evenly spaced skip pointers can be used. Now coming to positional postings and phrase queries, we can expect like there will be a many technical concepts or even multi-word compounds and phrases. So if we take Stanford University, it need not to be matched with a sentence which is like the inventor Stanford Oceansky never went to university, where that sentence is having Stanford and university. So now the most recent engines are allowing the double quotes as well, where the Stanford University is taken so that it wouldn't be dissected and searched as Stanford and university individually so that it can be matched with the wrong sentences. So in this section, we will be discussed with two approaches such as byword index and positional indexes to supporting phrase queries and their respective combinations.